Today my wonderful group will be discussing correlation and regression. We will be giving a few examples to hopefully help you understand a little better.
Correlation is derived from the prefix co, meaning together, and the word relation. It is defined as the mutual relationship of two variables. Remember, correlation is not causation. Regression is a statistical technique for estimating the relationships among variables. It can be used to find the equation of the linear line y equals a plus bx is the equation for regression, which is the statistical basis of prediction. Y indicates that we are making a prediction of a score on the y variable. A is the point at which the regression line intersects the y-axis. B is the slope of the regression line, or the regression coefficient. X equals the predictor variable.
Are children who are spanked more aggressive? Well, here's how we would determine if there is a correlation or not. First, ask parents how much they spank their children, and then measure how aggressive the children are. And finally, see if these measures are related. After getting the numerical data, we can use Fathom to insert the results of your research and create a scatter plot. From this scatter plot, you should be able to see whether this data has a positive or a negative correlation. Marjorie Gunno and Carrie Mariner took data from 1,112 children ages 4 to 11 in the National Survey of Families and Households. Regression analysts within subgroups yielded no evidence that spanking fostered aggression in children younger than 6, and supported claims of increased aggression for only one subgroup, 8 to 11-year-old Caucasian males in single-mother families.
Here's an example of a perfect positive correlation. Positive correlation is when the values increase together. Here's an example of a perfect negative correlation. Negative correlation is when one variable increases and the other variable decreases. Here's an example of a set of data with zero correlation. The values of a set of data with no correlation have no relationship with each other. A perfect correlation of positive or negative one occurs only when the data points all lie exactly on a straight line. A correlation greater than 0.8 would be described as strong, whereas a correlation less than 0.5 would be described as weak.
I'm back. Here's an example of a correlation done in running research. Steve Magnus, an ex-distance runner who competed for Rice and Houston University. After graduation, he was hired to work for Nike by Alberto Salazar, one of the greatest coaches in the world. He coached Mo Farah and Galen Rupp, who finished first and second in the men's 10,000 meter at the London Olympics. Steve Magnus had this idea that doubling in distance runs is more effective than one continuous run. For example, if you have a 6-mile run, instead of doing it in one consistent run, you would run 3 miles, wait an hour, and then finish the last 3. This gives you what he considers a more quality run. Unfortunately, he and Salazar had disagreements on coaching styles, so Magnus left to coach at Houston University. There he was able to carry out his research on doubling. He trained a group of mice on little treadmills over a period of time, one doing a consistent run and the other group doing doubling. After training them, he raced them and found the mice that were doubling were faster. He also tried this on his team at Houston University, and the runners have been running faster and faster. This established a correlation between doubling and time in a distance run.
Now for a quiz. What would you say this type of correlation is? If you said positive, you're correct. Now what about this type of correlation? The answer is zero correlation. Now, which of these has a stronger correlation? 0.41 or negative 0.99? The answer is negative 0.99 because it is a stronger negative correlation.
So the moral of the story is, make a scatter plot because it may reveal data and relationships that are hidden to the naked eye. Correlation varies in direction and strength, and regression is the line of best fit, and it uses known values to create a prediction.
Our resources were Wikipedia, Math is Fun, JAMA Network, and OpenStudy.com.